Hey everyone, 안녕하세요 여러분. This is Madam Sheila and we're gonna go through the sample questions for operating system concepts part 2. Let's go. Okay, for question 1. The mark allocated for this question is 4 marks and this is how the question sounds like. Briefly explain one key point why we should understand how an operating system works. And this is how we're going to answer it. As a programmer, understanding how operating system works may help to create a usable app across different platforms, simply because as almost all code runs on top of an operating system, knowledge of how operating systems work is crucial to proper, efficient, effective, and secure programming. Understanding the fundamentals of operating systems, how they drive computer hardware, and what they provide to applications is not only essential to those who program them, but also highly useful to those who write programs on them and use them. Next question, the mark allocated for this question is 3 marks, and this is how the question sounds like. End user and operating system programmer are among several types of users in a computer system. Briefly describe the different perspective between them. End user uses the system. They look for a system that is easy and user-friendly. Operating system programmer needs to know how to serve end users by creating a system that is easy to use. They need to understand the communication between hardware so that they can provide better service to the user. Continue. End users are the ones who use the application in the operating system, whereas programmers are those who create it and the ones who ensure its capability on carrying out such tasks. Different perspectives are in between them, such as the programmer creating the platform or application of the system, which is the back end, whereas users can only appreciate the functionality of the program or platform provided by the program. Next question, question 1C. The mark allocated for this question is 4 marks, okay? And this is how the question sounds like. Different mode of operation needs to be used to ensure the correct program is executing. Briefly explain the 2 basics mode of operation. Okay, so this is how we're going to answer the question. Mode bit is added to the hardware of the computer to indicate the current mode, kernel or user. With the mode bit, we can distinguish between a task that is executed on behalf of the operating system and one that is executed on behalf of the user. There are 2 modes. The first one is user mode. When the computer is executing on behalf of a user application, the system is in user mode. Kernel mode, supervisor, system mode, privileged mode. Hardware starts in kernel mode. The operating system is then loaded and starts user applications in user mode. Whenever a trap or interrupt occurs, the hardware switches from user mode to kernel mode. Whenever the operating system gains control of the computer, it is in kernel mode. 2, and the mark allocated for this question is 4 marks, okay? This is how the question goes. Elaborate on the point that resource allocation is one of the important services provided by the operating system. And this is how we're going to answer it. Running processes requires resources. When there are multiple processes running at the same time, resources must be allocated to each of them. The operating system manages different types of resources. Up next, question 2B. The mark allocated for this question is 4 marks, and it goes like, explain one benefit of using API rather than direct system call. You can answer any one of the following. Program portability. The program can be compiled and run on any system that supports the same API. Or Actual system calls are usually more detailed and difficult to work with. Question 2, C. What are the two models of inter-process communication? For this question, we'll give you 2 marks if you get it right. So this is how we're gonna answer it. The answer is shared memory and message passing. Question 2D. Why applications are operating system specific? The mark allocated for this question is 4 marks, and this is how you're gonna answer it. Each of operating system provides a set of unique system calls, and just like that, you get 4 marks. Question 3. A. The state of a process is defined in part by the current activity of that process. Draw the process state diagram to show how the process may change state. The mark allocated for this question is 3 marks, and if you draw it correctly, you'll get all 3 marks. And this is how you're gonna draw it, okay? And properly label everything. Alright. Question 3B. Where do we keep all information about a process? State 3 types of information that we can find in it. The mark allocated for this question is 2 marks. The answer is process control block, or PCB, or process task block. Okay, and you can answer any 3 of the following: process state, process number, program counter, CPU registers, CPU scheduling information, memory management information, accounting information, or input-output status information. Question 3C. What will happen when the process is allocated with a CPU core and is executing? 2 marks. You can answer any of the following. The process could issue an input-output request and then be placed in an input-output wait queue. Or the process could create a new child process and then be placed in wait queue while it awaits the child's termination. Or the process could be removed forcibly from the core as a result of an interrupt, or having its time slice expire and be put back in the ready queue. Question 3D. Let's say you are using your Microsoft PowerPoint to prepare for your class presentation, but suddenly you switch to the Chrome browser to find more information. When you go back to your slide, the cursor is still at the same place as you left it before. How is this possible? 4 marks for this question. Well, the answer is by having context switch, where the state of the currently running process will be saved and the new process state will be loaded. The process control block will be updated with the current state. Later, the state will be restored to resume operations. Question 4A. What is the difference between a process and a thread? 3 marks for this question. Process. It takes more resources, while thread takes less resources. Process consumes maximum time to stop, while thread consumes minimum time to stop. Process is a heavyweight process, and thread is a lightweight process. 4B. Briefly explain one benefit of multi-threaded programming. 3 marks for this question. You can answer it by saying responsiveness. Multi-threading, an interactive application, may allow a program to continue running even if part of it is blocked or is performing a lengthy operation, thereby increasing the responsiveness to the user. This quality is especially useful in designing user interfaces. For instance, consider what happens when a user clicks a button that results in the performance of a time-consuming operation. a single-threaded application would be unresponsive to the user until the operation had been completed. In contrast, if the time-consuming operation is performed in a separate, asynchronous thread, the application remains responsive to the user. Or you can answer it like this: resource sharing. Processes can share resources only through techniques such as shared memory and message passing. Such techniques must be explicitly arranged by the programmer. However, threads share the memory and the resources of the process to which they belong by default. The benefit of sharing code and data is that it allows an application to have several different threads of activity within the same address space. Or you can also answer it like this: economy. Allocating memory and resources for process creation is costly. Because threads share the resources of the process to which they belong, it is more economical to create and context switch threads. Empirically gauging the difference in overhead can be difficult, but in general, thread creation consumes less time and memory than process creation. Additionally, context switching is typically faster between threads than between processes. Or you can also answer it like this: scalability. The benefits of multi-threading can be even greater in a multiprocessor architecture, where threads may be running in parallel on different processing cores. A single-threaded process can run on only one processor, regardless of how many are available. Question 4C. Give one example to show that a thread is an action. 3 marks for this question. We can answer it like this: a word processor may have a thread for displaying graphics, another thread for responding to keystrokes from the user, and a third thread for performing spelling and grammar checking in the background. Okay, the last question, question 4D. How is thread supporting the multi-core processor architecture? 3 marks for this question. Here's how we're going to answer it. Some threads can run in parallel because the system can assign a separate thread to each core. So that's it, guys. Thank you for staying till the end of the slide. I'll see you next time. Bye-bye.